So I just want to quickly run you through our implementation of HTML pattern matching and HTML file validation using a stack data structure in Java. So to begin with, we'll have a look at our interface for the stack, which has the standard methods, the basic ones: push, pop, and getHead, where push is to add something into our stack, pop is to remove something, and getHead is just to get the first element in the stack. We have three different implementations of the stack. We have ArrayList, array, and LinkedList. So I'll start off with the simplest one, which is the array stack. So the attributes that this has: it has capacity, which is set to 10. It has entries, which is the pointer, and it uses a basic array as kind of the underlying structure. In the constructor then, we set up initialize our array with the capacity that we've defined. We've got this push function, so you can see here that we implement the stack. So obviously we're going to have to implement the methods that we've defined in here: push, pop, and getHead. So here's push. So in here, when we try to add something to our stack, we say entries plus plus to increment the pointer. And if all goes according to plan, then we'll just take the data that the user is providing and we'll say, okay, this is going to go now to the top position in the stack. But otherwise, if the user tries to add something with push and we've already reached capacity, which is set to 10, then we'll just double the capacity. So down here, we can see how that works. All that does is it finds out the capacity we have now, which is 10. It'll double it, get 20, and then it'll make a new array with that double capacity. It'll copy over all the values that are in our existing array, and then it'll just update the value of our current array to this newly created bigger array. If that fails, then we'll throw an unsupported operation exception. We won't actually add the thing that the user wants to add, and we'll decrement the pointer because it was added incremented at the start here. Pop then is very simple. If there's nothing in the array, then we'll just throw a runtime exception. You can't remove from the array because there's nothing there. Otherwise, we'll just remove the entry that the user wants to remove and decrement the pointer, and then return the tag that the user has removed. GetHead then, obviously that just returns back the first element in the stack. For the next implementation, I suppose it's more complicated in the sense that it's using a more complicated underlying data structure, but it's actually, there's less code involved, because in this case we're using an array list and we can just utilize the underlying methods that the array list provides to us rather than having to write them ourselves. Like with the double, so obviously with the array list it isn't of a fixed size, so we're not going to need that double anymore. In this case, if someone wants to add something to the array list implementation of the stack, then it's no problem. They're going to be able to do that in any case. The pop now is pretty much the same. If someone tries to remove something and there's nothing in the array, then obviously they can't, so throw an error in that case. Otherwise, we're going to remove from the top of our stack and return the tag that the user is trying to remove. Obviously, I say tag in this case. The keyword we're using is tag because we're dealing with HTML tags, so we won't say something like node or anything like that. And then again, this is pretty much exactly the same as our implementation in the array. We return the top element in the stack. The linked list then, that kind of consists of two smaller things. We have the linked list stack itself, and then we have the node, where the node just represents one kind of data point in the chain in the linked list. That in itself then has these two attributes. It has data, which is what it sounds like. It's the data that the node is going to store. And then it has this node, which represents the next node in the chain. So the attributes that we have inside linked list, then we have a node, which is going to represent the top node in the linked list. Push then, rather than dealing with a pointer, we're just going to instantiate a new node and pass in the data that the user has provided the push function. If there's nothing already in our linked list, if it's empty, then we'll say that the top first element in the array list or in the linked list is going to be this newly created node. Otherwise, then we'll take this newly created node and we'll say, okay, the next attribute for this is going to point to whatever element is already in the top position in the linked list. And then we'll set top to new node. So the node that we just made, that gets set to the top, and the other one, it says, okay, you can now point to the node that we just added to the top. Pop then, it's kind of just the inverse of that. Set the next pointer for the value that the user just passed in, and then return that value that we popped off. GetHead then is pretty much the same. We just return back the very first element in our linked list. As I said, this is about validating HTML files. We've tested this pretty extensively with over 800 HTML files that we got from Kaggle. But to show how the specifics of this work in terms of the HTML, we have some constants. All this does is just, these are kind of specific HTML tags that are self-closing, so we make an exception for them when we're doing our parsing. We have this HTML file reader, which is kind of just a helper for the HTML file checker itself. This one is the main thing, but obviously we need to be able to read in the HTML file. So in here, we just have this read file method, which returns a string. It uses the buffered reader to read in the HTML file and build up an array of all the HTML tags it finds and return them at the end. In this extract tags function, as you'd expect, we're just doing some regex to figure out, as we parse through this file, what is actually HTML and what's just, actual text content or comments or anything like that. So we remove that stuff to make sure that we're only dealing with a real list of HTML tags. Inside the file checker then, okay, we pass in a stack. It can take any kind of stack, so it could be our array list, our array, or our linked list. But in the constructor for the HTML file checker, we provide a stack. Whatever stack it's using then, it has this check to say is tag self-closing. As I said, we have an exception for them inside this HTML constants file. So it just checks to see if it's inside the self-closing tags that we've defined. But otherwise, it's going to run this is HTML file valid function. It'll instantiate a new HTML file reader to read in the file. It'll get the list of tags, and then it'll iterate through all the tags that it finds in that file. It'll ask itself, okay, is there a / at position 1 in this tag? And if so, that means that it's a self-closing tag. Or sorry, it'll check if there isn't a / at the start, because that means that this is the first tag in a tag pair. In that case, if there's no / at position 1, it'll push it on to the stack. And then otherwise, if there is a / at position 1, that means it's a closing tag. So it'll ask itself, does the tag at the top of the stack, using getHead, does the first tag that I see at the top of the stack equal the tag that I just came across with the / in it? And if so, then that's fine, because they're a pair of tags. Say, for example, if you were to have a div tag, you'd have one that doesn't have the / and you'd have another one that does have the / in position 1. So if we see a pair like this that matches the first one in our stack, then we say, okay, that's valid HTML, that's fine. And it'll pop off the top element from the stack. Otherwise, if it's encountered, say 2 tags, say if it got an opening div tag and then it followed by another opening div tag, well, that's invalid HTML. So we just return false to say, okay, our HTML isn't valid. But if we iterate through the entire list of HTML tags and get to the very end and we haven't found anything invalid, we just return true to say, yeah, this HTML file is valid. I can show you how that works. So in the main file here, we've got 3 different types of stack: the array list, the linked list, and the array. We instantiate a HTML file checker and just run, in each case, HTML file checker that is HTML file valid with our file path, which is this dummy HTML file, which is some very basic HTML to check against. You can see we've got some meta tags, which is going to be self-closing, so that'll be one of the exceptions. A BR tag, it'll disregard this CSS code as well, using our regex matching. There's another one that would be an exception using our self-closing tags there as well. So I'll run it, and we should see printed out true, 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 because in every case, our file checker has found that the HTML is valid. But I could go in here and say, for example, I'll put in a div, just an open and div tag with no close. I'll run it again, and we get false, 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 because that's invalid HTML. We have a div that opens and doesn't close. And then just for a quick overview, I have our UML diagram, and you can see this follows the same pattern that I would have described to you just there. We have this stack interface, which is implemented by the array list stack, the array stack, and the linked list stack. And then dependent on kind of a constituent of this linked list stack is the node. The HTML file checker then, it receives a stack as input. In the constructor you pass in a stack, and then the HTML file reader or HTML file checker also gets passed in a HTML file reader. So they're all kind of codependent on one another in that sense. So hopefully that was enough of an explanation. There should be some comments in the code too to go into a little bit more detail if it's needed. Thank you very much for watching.